a capacitor of capacitance C is given a charge Q at t equal to 0. It is connected to 0 second. It is connected to an uncharged capacitor of equal capacitance through a resistance R. Find the charge on second capacitor as a function of time. Solution: let any instant the charge on the uncharged capacitor is Q. The charge on the charged capacitor remains Q minus Q. Now the circuit diagram is here shown. This is our uncharged capacitor, which is charged with charge Q, and this is our charged capacitor with charge Q initially. Now at time it have charge Q minus Q. So we can use the charge on the charged capacitor remains Q minus Q. Now using KVL, so minus IR minus Q by C plus Q minus Q by C equals to 0. This imply I is equal to dq by dt, so minus dq by dt R plus Q minus dq by C equals to 0. This implies dq by t R equals to Q minus 2Q by C. Again, so taking now dq by q minus, this implies dq by q minus c equals to dt by rc. So integrating from 0 to q, dq by q minus 2q, because our variable is q, and 0 to t dt by rc, here variable is t. Now its integration will be log q minus tq by minus 2, because this is constant multiplied by q, so it will be in the denominator, and limit will be 0 to q equals to t by rc. So now 2 is taking this side and putting the value of limit. We have this implies log q minus 2q minus of log q equals to minus of 2 into t by rc, or log q minus 2q by q equal to minus of 2 into t by rc, or this implies 1 minus 2 into q by q equals to e to the power minus 2 into t by rc, or this implies 2 into q by q equals to 1 minus e to the power minus 2 into t by rc. So q equals to q by 2 1 minus e to the power minus 2 into t by rc. So this is the this value is the charge on second capacitor in terms of charge on the first capacitor and with respect to time, given by this. It is a function of time. Next, a capacitor of capacitance C is given a charge Q at a t equal to 0. It is connected to an ideal battery of EMF E through a resistance R. Find the charge on the capacitor at time t. Let Q be the charge on the capacitor at any time t. Now, and Q is the initial charge, capital Q is the initial charge, and Q dash is the final charge on capacitor. Applying KVL, minus IR minus Q by C plus E equal to 0, or minus dQ by dt R minus Q by C plus E equal to 0, or this implies dQ by dt into R equals to E minus Q by C, or dQ by E minus Q by C equals to dt by R. So integration from Q to Q dash, dQ by E minus Q by C equal to 0 to t dt by R. or log E minus Q by C by minus 1 by C, Q to Q dash T by R, taking this in this side. Log C minus Q by C in the limit Q to Q dash equals to T by minus RC. This imply log E minus Q dash by C minus log E minus Q by C equal to minus of T by RC, or log E minus Q dash by C minus Q by C equals to minus T by RC, or equals to E minus Q dash by C by E minus Q by C equals to E to the power minus T by RC. This imply E minus Q dash by C, and taking this in this side, E minus Q by C into E to the power minus T by RC. So finally we have this value. So finally we have CE minus Q dash by C equal to CE minus Q by C into E to the power minus T by RC, or equals to CE minus Q dash equal to CE E to the power minus T by RC minus Q into E to the power T by RC, or we are left with this value. So CE minus C into E to the power minus T by RC plus this value taking this side, Q into E to the power minus T by RC equal to Q dash. This is our final value. Hence Q dash will be Q into E to the power minus of T by RC plus C into 1 minus E to the power minus T by RC. Answer. This is the upper final answer of the above problem.